Hello guys, you're welcome to lesson 3 of our robot structure analysis course, and today we are focusing on reinforcement design and detailing. If I recall very well, last time we talked about applying loads to your members, we talked about assigning supports fixed and pinned to your beams, we talked about analyzing your displacements, your deflections on slabs and beams, and how you would structure overall deflects when the loads are applied to it. So now in the next component, which is the lesson for today, we are going to focus on reinforcement design and detailing. And by the end of this session, we should be able to generate reinforcement designs, adjust them to code requirements, and later on we are going to export this to Revit and some other BIM software. Now, uh, robot supports a number of international design codes. We have Euro codes here, we have got BS8110 and some other codes, but like I said at the start of this program, we are going to focus on BS8110, which is the code that we're using for design of concrete elements. Now, uh, before I start, I need to also mention that the reinforcement that you're going to generate in robot structure analysis may be slightly different from what you're going to detail to the contractor, depending on the type of contractor you're working with. Sometimes it's better to just keep it simple. Sometimes robot will give you reinforcement that's cut. It will put like a lot of bars where there's high moments, and then sometimes it will cut the bars where you don't need any reinforcement. It will not give you the bars. But depending on the scale of the contractor you're working with, sometimes it's better to actually just continue the bars throughout and not have them cut, depending on according to the moments. So I'm going to demonstrate this further on as we continue in our lesson. Okay, so now we've run the analysis, we've analyzed our many moment diagrams. Just to do a quick recap, you can see where we have the maximum and the minimum moments. You can also check out the deflections, deformations for bars. You can see your deflections. There you go. Under service loads. So basically we've done all this. Now we're moving on to design. So I'm just simply going to go to view and show my members. So to start with, I'm going to choose one beam. So the way we design beams in robot, the preferred way of doing it is you select your beams like this. Now you can select by holding control. So this enables you to select the number of beams at once. And then I'm going to just open this in a new window. Let me just confirm that we are recording. Okay, this is fine. Now, I've opened this in the new window. Let me just quickly check my results again, my pending moment diagram, and let me turn off the deflections. Okay, perfect. So, we want to check out the reinforcement design for this beam. Now, there's a number of things you can do in robot structural analysis as far as designing of reinforced concrete elements is concerned. You can specify the type of bar size you want to use, the type and the bar size you want to use, whether you want to use Y20, Y16. You can specify the cover, you can specify the anchorage settings. You can also optimize your layout, your detailing parameters to meet standards that are on site. And yeah, a few other things you can do. Now, when you're designing elements in robot, you simply select the beams and then you go to design under provided reinforcement of RC concrete elements. Now it's going to bring up this window. Now here you need to make sure that the combination that you are selecting is a manual combination, because this is the ultimate limit state that's going to be used for design. We don't use simple cases, we use manual because you define your ultimate and your service states. Then you go ahead and say okay. Now there we have our beam. Now the beam is going to display the spans from center line to center line, and then it's going to show you your supports. Here you have got 0 0.4, 0 0.4, 0 0.4. These are your columns. And, if you can compare this with the model, you would realize it's pretty much accurate. And here where you've got your V6, hope you can see my cursor. This is now a secondary beam joining to a primary beam. So we don't have a column here, but we simply have a secondary beam joining in. Now, this is how you set up your parameters. Before you do any design, you need to tell robot what type of steel you need to use, what type of cover, what size of cover you need to use, and the type of anchorage you want to use. Now, how you do that, you go to calculation options. Here under general, you have your options for cover. Here you can choose to fix this. I would prefer we go with 30, which is okay. And then you go into your concrete. The concrete we're using C30, this is fine. And then the unit weight is also given there, which is okay. Aggregate is fine, not much of a problem. Then here, longitudinal reinforcement. Here you have to select your T, which is high yield steel. And then you uncheck everything else. I prefer using Y16 because it's the most commonly used bar size for simple structures like buildings. It's easier for contractors to work with. If you're using steel that's too large, if the diameter is too big, like Y20, 120, Y25, or Y32, it might be a bit difficult for the contractor to bend it on site. So just keep that in mind when you're doing your design, that we need to use something that is as simple as possible, especially when working with local contractors who don't have the capacity for bending and all these complex operations that go on site. So my longitudinal reinforcement is defined. I'll go into my transverse. Again, here, let me choose this one, R10. In some cases, you might use R8, but I would prefer we use minimum R10 because this type of steel, the R steel is not always reliable on the market here in Zambia. So you're better off using at least R10 for your design. You can actually use Y10, but for this example, let's stick to R10. Then additional reinforcement, I would prefer we simply use Y12 because the additional reinforcement is not used as structural steel. It's not supporting any loads. It's just there to help finish up the detailing, and maybe if you need to connect bars from one span to the other, maybe just to complete the detailing process. It's not structural in any sense. So I'd prefer we simply use Y12, which is okay. Now, if I want to use these parameters next time I do my design, I can simply save this as something else. Let me call this BMG beam parameters. Okay. So once I save this, make sure I save it. Once I save this, the next time I'm trying to design a beam, I'm simply going to come here and select my parameters, and all these settings are going to pop up and they're going to be selected. I'll simply say okay. Now I'll need to move on to the reinforcement pattern. Here, the settings are pretty much self-explanatory. You simply have to choose your preferences. One thing to note is the length of bars. Here in Zambia, we always the reinforcement length we use is 12 meters, so this is okay. I think the software is pretty much accurate on this one. We're using 12 meters in Zambia. The minimum diameter is 10. You can leave this because I think the minimum we selected is 10 in our settings. And then bent bars, I don't want to play around with this. This is fine. Then the anchorage type I prefer to use. I like using the first one. The first one looks okay. These are just simple settings that you can always try to experiment with depending on your preferences. Now, um, I'm simply going to go into the bottom reinforcement patterns, and here the number of layers, the maximum number of layers is 2. This is okay. I don't want to have so many layers. And then the minimum diameter, let's put it at 12. Let's put this at 25, the maximum diameter. Then here, the n max, I like to leave it at 3. Considering the size of our beam, we are using 400 by 200. So if you have 4 layers, it's going to be a lot of steel inside. There's going to be issues to do with spacing of the bars. And minimum is 2. This is fine. Then top reinforcement, a similar story. Here I can simply check as bottom reinforcement, and all the settings I applied for the bottom reinforcement are going to be applied here. Transverse reinforcement, I like to leave these 2 options. And here the spacing of the stirrups, here you need to make sure that it's in multiples. I like to leave it in multiples of 50, or you can use 100, which is 0.1. And the spacing multiplications, the constrained reinforcement. Again, these are just some other detailing parameters you can always play around with. They don't really make so much of a difference. It's based on preference. And this is to do with the bar bending schedule. Now, remember, like I said, you can always save this BMG settings, beam settings. Okay. Once that is done, we say okay. Now, I think that should be pretty much it. Let's go on now to calculate our reinforcement based on the parameters we've assigned. I'm simply going to go here and say start calculations. Calculate. It's gonna take a minute. Okay, so we've got a number of issues here. The capacity for bending is not sufficient. This is probably because we're using Y16 and some spans which are long. Moment is too high for the steel that we're using. So we can always go back and try to use a larger diameter like Y20 or Y25. Now, perpendicular cracks and all that. So usually with these warnings and errors, you simply have to go through them one by one and see what you can adjust on your beam to make it, to make it pass the design, calculation. So here, under beam diagrams, this is going to show you your bending moment diagrams for the entire beam. It's continuous beam here. Remember, I said where you have your supports, it's going to show a column there. And then the green line, this is the bending moment that the beam is actually experiencing from the load that you've applied to it. So the green line represents your bending moment diagrams, and the red line represents the capacity your reinforcement has to actually withstand the bending moment. So in every span or on every support, you need to make sure that the red line is way below the green line. This shows that your reinforcement has sufficient strength to actually bear the bending moment, which is a green line. So in this case here, I'm sure you saw the warnings we got when we were trying to do the calculation. You can see here that where my mouse is, the red line is extending beyond the boundary of the green line is extending beyond the red line, and this is because the bending moment is way higher than what our reinforcement is capable of bearing. So we need to see how we can work around that, probably by adjusting the size of the beam, make it deeper, or using maybe y20 or y25, increasing the size of the steel. Now, this is, I think, it when it comes to the beam diagrams. You can always change these parameters. This is just a table showing you the supports and the spans and where you have your moments, your critical moments, and a few other things. This is pretty much good. You can use this to, you can copy this to Excel, you can put it in a report or something later on. And here you can simply also choose what type of diagrams you want to see. You can also choose service, and there's so many other options that I'm not going to go into details discussing here. These you can easily try to experiment on your own. I'm just trying to show you what you can do with this is you can easily experiment. Now let's try to go under beam reinforcement. Here we see that the beam has been reinforced. However, we should be aware that the software has given us a warning. You can see that we're having too much steel on certain areas like here, which is not realistic. We can't use this because there's too much steel, and like I said, we already have warning. So let's go back and try to fix this problem. The first solution I would recommend in this situation is to increase the beam depth where we have issues to 500 or 600. So we can see that the longer span here on the right side, this is where the issue is with the bending moment diagram. So we simply have to go back to our model and change the size of the beam. So how do we do that? We go back to structure model geometry, and yeah, and then there we have our beam, and I think these two beams here, 28 and 27, they need to be deeper. So let's change this to 200 by 500. Now, in case you're wondering how we are changing the size, you can simply go to your member sections. Here you've got, I've already defined my sections. This is 200 by 400, 200 by 500, and etc. Now you can easily define your new size of the beam. You can choose the concrete size, you can the material, sorry. Then you can also choose the dimensions, which I've already done, and once you add that, it's going to be added to your database in robot, and you can assign that cross section to your beam like I said. So um, you simply click on your beam and assign your section here. Okay, so let's go back to our concrete design. You can simply go back to your design by going here, RC component inspector, go to story 1 and check on your beam. Okay, perfect. So now we've changed our beam size. Let's try to recalculate and see what we are going to get. Okay. One more step. I think you need to update your elements. This is not supposed to be. Okay. So now once you update, we can do run the calculation again. Okay, so we've got fewer errors now. Perpendicular cracks, axial force is not. So this is just a warning about axial force is not important. The one that's actually important is this one that talks about the capacity for bending. So it shows that our beam is still not good enough because we are not satisfying the bending moment. So most of these errors are actually coming from the spans that have occurring heavy moments, and this is span number 5 if I'm not mistaken. 1, 2, 3, 4, 5. So we see that we still haven't finalized our design. We're looking good on the other spans here where we don't have a lot of moment, but we still have issues. On the other end here. So again, let's try to use Y20 now. Okay. Okay. So finally, the beam has been designed. The Y20 has worked perfectly because now we've got 3 Y20 and 3 bottom and 2 Y20 on the top, which is fine. So what I did is I changed the size of the concrete beam, which is now 200 by 500, and I increased the longitudinal reinforcement to Y20, which is now fine. Now you can always check your beam note and see how the software is calculating your reinforcement, the loads it's using, and all these other parameters. It shows you the bending moment diagrams, the shear force diagram, the deflection diagrams, and everything else you need. Now, the next thing you might want to do is check out your drawings. If you come here under drawings, it's going to show you uh, your drawings. These are not so good, so I recommend actually that instead of using these drawings, you take your model to Revit, which is what I'm going to show you in the later videos. Take your model to Revit and do the detailing there. It's much easier and it looks a lot more professional than the drawings that you're actually getting on it. So I think this is it for beams.